stars like the sun? How did galaxies form and evolve? How do you take, the messy, clumpy little things that form out of the Big Bang, or after the Big Bang, which we're just really starting to discover? How do you take those early proto-galaxies and then they merge with other galaxies and form lots of the stars and make big, beautiful spiral galaxies like our own home, the Milky Way? How did all the elements that we're made of, the carbon, oxygen, nitrogen, iron that's in our bodies, how did all that get made? We know that those elements are all made in stars. When did those stars form those elements, and how did those elements disperse through the universe and get into stars and planets like our Earth?
That's just big picture answers.
So just
there.
the whole process of how do you make us, right?
Okay. That's
And then those proposals get read by a team of experts, actually a couple hundred experts, and they get ranked. And that whole process is done it's done anonymously, without the people that are reviewing the proposals knowing who wrote it. So it's not, like the rich and famous have an inside track. And then most of those proposals go down in flames. And a small minority of those proposals are accepted just because we get more ideas than there's time on the telescope. So we accept the highest ranked proposals, and then we figure out how to schedule it, of what, every week we generate a new schedule of what are the observations that will happen each hour in each day of the week. Observatory is just carrying out those observations. And so we're already seeing a bunch of new, every day I go in and I say, okay, what's new? What's the new data? Some of those will make it to big splashy pictures and papers, in the newspapers. And others will just be more of the scientists will geek out and learn stuff. I think the big picture here is that we don't know what the big discoveries are going to be. We know what we're going to look at. We're going to look at a lot of planets orbiting other stars. We're going to look at a lot of distant parts of the universe and really try to find these early galaxies and understand how galaxy formation got started. And then there's probably lots of stuff to be discovered in these data that we haven't discovered yet. And so that's the surprises that are coming. The surprise for me so far has been how smoothly commissioning went. We had binders and binders of plans for how to commission this telescope. And really, we just did the plan. And it was a tremendous amount of work, and it worked the way it was supposed to. And with a lot of those contingency binders of, okay, what if this goes wrong and what if this goes wrong? We just got to throw those out because it worked the way it was supposed to. That we released were parts of our kind of new, kind of well, so it was a mix of sort of some old favorites and a new light. Like the Stephan's Quintet, those merging galaxies, and things like that beautiful lensing cluster, the deep field, where we knew sort of what that looked like from Hubble, but we're seeing it with a clarity at a depth that we've never seen. And there are tons of galaxies in that image that are just completely invisible to Hubble. And so that is an expected surprise, right? Okay. We knew there ought to be very distant galaxies that are so red because they're so far away, their light's been redshifted, that they're just invisible to Hubble, and they should pop right out when we look at them with JWST, with the Webb telescope. And that's absolutely what we see.